Awesome, great. Okay, hi everyone. This project is looking at how to use augmented reality to visualize embodied carbon. So first off, what is embodied carbon? Some may be well aware of this concept, but it can be a new concept for many people. This is really referring to the carbon emissions associated with all of the construction materials used on projects. So all the concrete, steel, wood, glass, insulation, all of those materials, they have impacts associated with the resource extraction, transportation, manufacturing, processing, construction, operation, end of life. So throughout all of those life cycle stages, what we do is we actually quantify the carbon emissions of those supply chains and basically figure out what is the associated emissions for building the building in the first place. This is important because it actually makes up a big chunk of global CO2 emissions. So if you look at this graph, this is a chart of global annual CO2 emissions. And so 28% goes towards operating all of the buildings on the planet each year. So that's the heating and cooling. That's what we're used to focusing on for a lot of our green building efforts. However, what's oftentimes neglected is this 11% slice of the pie, which is associated with all the new construction and major renovations, all the embodied carbon associated with those materials. And what's more is that if you look at some of the key materials, concrete, steel, aluminum, which are obviously used not just for buildings, but for infrastructure and other sectors, even just those three materials makes up almost a quarter of global CO2 emissions. And so if we can change these supply chains, that can make a big impact on global CO2 emissions. Now, if you look at a typical project or the lifespan of a building, the yellow parts are what we're used to optimizing for. So that's the operational carbon emissions for heating and cooling and operating the buildings. But the pink portions are embodied carbon. So there's a big pulse of upfront CO2 emissions from all of the construction materials used to build the building. Plus there's replacements and maintenance throughout the lifespan of the building, and then some emissions from end of life. So these are, to quantify embodied carbon, we need to do a life cycle assessment. So we're really looking at all these different life cycle stages. So as I mentioned, raw material supply, transportation, manufacturing, construction, use, end of life, etc. This is important because typically the thinking has been that operational carbon emissions is far more important than embodied carbon. But what we're seeing is that depending on where you're located, the climate, the energy performance of the building, and also the carbon intensity of the electricity grid of your state or province, we can see that actually as the operational emissions, the gray section, goes down over time, the embodied carbon becomes a bigger slice of a smaller pie. And so this is actually true in British Columbia, where I'm from, in Vancouver. So we have what's called the BC Energy Step Code. You can see this is the operational carbon emissions. So this is expressed in kilograms of CO2 per meter squared of floor area per year. So you can see, depending on the step code, as you get higher in the steps, that's higher energy performance. We already have actually very low carbon, operational carbon emissions. If you're going into electric buildings, they're under 2 kilograms of CO2 per meter squared per year. And even natural gas buildings are, let's say 15, maybe a typical building, maybe 20 kilograms of CO2 per meter squared per year. Now, this is the range for embodied carbon. So it's typically anywhere in the range of 100 to 1,000, with many projects coming in the 200 to 600 range. This is a study of 1,000 whole building LCAs done around the world. Now, what I do is life cycle assessment. So that's what I do. I'm an LCA consultant. And so what I would do is take a Revit model, and first I'd have to do some cleaning up of the Revit model, but then map all the materials in that Revit model to these databases that have kind of emission factors for the concrete, steel, et cetera. And so the end result of our LCA studies could be something like this, where we have a chart that shows you the kilograms of CO2 per meter squared of floor area. So in this case, for this project, it's about 528 kilograms of CO2 per meter squared. And you can see how it breaks down by different building elements, by different material types. So this is typically where we end the story, right? Like we give this report for LEED or for green building rating standards or for policy reasons or just to the client in general. And most people can't really relate to what these numbers actually mean. So this is where the AR visualization comes in. Carbon emissions are invisible. So how do we actually make the invisible visible? What we're looking to do is actually create a compelling way to communicate to architects, to structural engineers, to developers, to clients, tenants, policymakers, and the general public about these hidden emissions, especially as it pertains to embodied carbon, which is something that we mostly don't think about. And what's interesting about augmented reality is that it gives an inherent sense of scale, just by nature of the experience. And so we can really visualize, for this AR experience, we're visualizing the volume of different construction materials used per meter squared of floor area for a specific project, and also the embodied carbon emissions associated with it. And this can be customized to reflect different LCA results for each project. So after doing an LCA result, we can scale this AR visualization, and it can become a marketing asset to communicate, different design measures that were used to reduce embodied carbon. It can be embedded into a website. It can be viewable on iPads and iPhones, the latest generations. Actually, the demo is not filmed with the latest version of the iPad Pro, but it has a depth camera, so it adds occlusion, which can make it even more compelling. And this will also be a relevant experience once Apple's AR glasses launches as well. So here's the demo. So you can see this is 1 meter squared of floor area. So what we're trying to do is quantify the amount of, first, the construction materials per that 1 meter squared of floor area. My AR visualization is kind of messing up a little bit. It's lost track of the floor for some reason, so bear with me. But these volumes are accurate. So this is actually the actual volumes from a specific project. So we quantified, in meter cubes, the amount of materials there. It's kind of hard to read here, but it's looking at what's the embodied carbon associated with all these materials. And so this shows you the graph that I showed you earlier, and that it's 528 kilograms of CO2, but what does that actually mean? So this is what 1 kilogram of CO2 looks like at standard pressure. So this is the volume of 1 kilogram of CO2. This is what 528 kilograms of CO2 looks like. And for this project, it's actually 10,000 meters squared, or around 100,000 square foot building. So you got to multiply this by 10,000 to get the full emissions. Now we're showing we saved 12% of the emissions, and so that's the amount of bubbles that kind of got portioned off. And we used physics to kind of simulate that crashing down. I know that was a bit hard to show, so this is just what it looks like in a computer, the same demo. So again, how much construction materials are used just for that 1 meter squared of floor area? This is the quantity. So there's this concrete, the concrete used in foundations, on floors, on roofs, et cetera, the amount of insulation that's used, the volume of aluminum and glazing, et cetera. Again, we're kind of showing through the embodied carbon associated with these materials. This shows you that graph, which can only communicate so much because we don't really have a sense of scale of what does a kilogram of CO2 even mean. And so this is part of the purpose of this visualization. And in particular, given the scale of this, given how big 528 of these balls are, this is just to kind of give you a sense of scale. So I'll transition into a zoomed out view. So this is what 528 looks like relative to just that 1 meter squared of floor area. And so we kind of portion off 12% of those bubbles, and then it kind of crashes down, which kind of gives an interesting, visualization of it. And that's basically it. So that's the demo. What did we use to build the demo? We used Apple's Reality Composer app, which is available on Mac and iPad. I actually previously was thinking about using Adobe Aero, but I found Apple's Reality Composer to be actually a really powerful app, so that's something new that I learned. I also use Apple Reality Converter to convert some of these shapes into Apple's file format, use Blender to create the shapes, and the LCA study was done previously, so this was, I didn't do the LCA study during the course of this project. I should mention that whole demo was filmed outside of Vancouver Public Library, but these results aren't specific to that project, but you can imagine if we actually filmed this on location on the actual specific project, this could be sort of a marketing asset in a way. And just finally, just a little bit about me. As I mentioned, I'm a life cycle assessment practitioner. I have a company called Priapta that just focuses on LCA consulting. I also founded the Embodied Carbon Network Vancouver, which is soon going to be rebranded to CLF, or Carbon Leadership Forum Vancouver. So we basically bring together a lot of professionals to focus on a range of embodied carbon topics. And I'm also supporting about 9 other cities along Western North America, Asia, and Australia to kind of launch these similar local hubs to engage local practitioners on that front. So, we're very passionate about driving radical reductions in embodied carbon globally. And I think this AR visualization has been something that's kind of been on my mind for some time, but it's been great to actually be able to build it yeah, so this is, and yeah, the visualization was definitely done over the course of this weekend. Actually, I think probably over the course of like 2 days, maybe, to build the whole thing. But then I spent some time also like kind of researching a little bit. Actually, it was built mostly in the past 24 hours, to be honest. And that's it for me. Thanks. And if you're interested in embodied carbon, feel free to connect with me and we can chat.